Welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. And also, if you haven't noticed, we have a technical blog where we occasionally, from time to time, will publish some Leetcode solution. So today we're going to look into this problem. Basically, it's called the basic calculator 2. So what is the basic calculator 2? So apparently there must be a basic calculator 1 where you can actually read the solution here. It's very similar, except there's no parentheses in this basic calculator 2. There's only plus, minus, multiply, and divide, and assume everything is valid. So if you have basically division, like 3 divided by 2, you just calculated the floor instead of the ceiling. So 3 divided by 2 is 1. 2 divided by 3 is 0. So the thought process is very, very similar to the basic calculator 1. Like I said, the difference is there's no parentheses. A generic way that I like to solve this kind of problem is to always keep 2 stacks. One stack for the operator, the other stack is for the operands. Still a few caveats. So the only difference is basically whenever you see a plus or you see a minus, I like to check the previous operator. So if the previous operator is star or plus, then it means it's time for you to do the calculation because multiply and divide has a high priority. However, if your current calculator is multiply or division and your previous one is plus or minus, you just need to basically keep pushing the operator to stack because right now we have a higher priority, so we need to basically we need to wait for later stage to calculate the things, or else we just do the normal calculation. A few caveats from this problem is I just noticed if you do the 2 to the power of 2 to the power of 31 minus 1, it will be actually this if you do a 0 minus. So if you try to use your solution, whatever the online solution right now, it won't pass this case because this actually will cause overflow. However, Leetcode, I don't think they have this kind of solution. That's why I just want to call out in those kind of situations, you probably want to use a long instead of integer in real interviews. And also this is very similar to the basic calculator 1. So pay attention to the order when popping out operands in the calculate. And also notice the number is definitely not just a single digit, right? So let's quickly look at the code in this example. So I actually have code here. So if you can literally just copy paste and then put a breakpoint and then see what is going on with these 2 stacks. But just to show it visually, for example, if we want to calculate things like this, right? So normally what I want to do is I would like to have 2 stacks like this. So we just run over one by one. So first of all, we see a character. So if it's a digit, so we just keep doing the number. And also this is very similar to the previous one. It's more like I use a string builder to keep accumulating the number. And once I see a sign, which is either one of this, then I will basically pass the long, or in this case, most of them are integer, but I use long because of the overflow case, and then push it to the stack so that I have operator. So for this specific case, so first of all, I will have a 1 here. I parse it, and then we keep going. And then what we're gonna have is we will see a minus. So once we see a minus, so first of all, we'll check, if the operator is already empty, so nothing we should do. We just literally push this. And now we continue, and then we will see a 2. So once we see a 2, so what we need to do is it's a number, right? So we just keep kind of like buffering the number into this number, and now we see a plus multiplies a star sign. Once we see a star sign, so now we know, okay, first of all we need to push this number into the stack, which is 2. So now we have 2 here. So now this is the interesting part. Once you see a star sign, right, and then you want to pick the current stack. What is the current stack? It is actually a plus or a minus. So if it is a plus or a minus, it means, okay, we shouldn't really calculate because this one carries higher priority, and then we need to calculate like this one later. So that's why we don't need to calculate. All we need to do is actually push this to the stack like a star. And now we continue. So now let's say if we basically continue reading the number 3, and then we basically number is 3 before we push it to stack, and then we read this sign is division. So now we're here again. So now if we're division, now we need to pick again. So we pick, oh, is this a plus or a minus? Well, apparently it's not. So that means we will fall into this else bracket. So what is in this else bracket? This is just a normal like calculate value function using operator and operands. So what this means is, so first of all, we have 3, right? So we put in the 3, and then we see now it's a division because they plus and divide, they share the same priority. So what we need to do in this case, we need to get this number out, 2 and 3, and then use this to do a minus, to do a plus. So now this number will become 6. So we'll push a 6 into the stack, and then we'll push a divide into this. This is also popped out into the operator stack. And now we just continue, right? So now we'll have a 2. So we basically push a 2 here, and then we reach the end of this whole like while loop. So now we check, oh, if it's number length less than 0. So this is we actually push the 2 to the stack. And then while operator is not empty, then we just keep calculating this thing. So basically we pop up 2, 6 divided, and then it's just 3. So now the stack we have 3. We get this out. We pop 1 and the 3 out, and then use a minus. So this will equals to -2. So this is essentially how this method works. This is a very generic method. Just keep in mind for those kind of like either it's a reverse Polish calculation expression or any kind of basic calculator, you can always just simply use this 2 stack. One is operands, the other is operator to solve those kind of problem. All right. Cool. So let's continue. So there's apparently, the time and the space complexity is all O to the power O of n because it's a linear, and because time complexity is linear, and the space complexity we do need extra stack, actually 2 extra stack, but doesn't matter. Another similar, just like a basic calculator 1. So there's another very similar way to solve this problem as well by using 1 stack. In the previous problem, basic calculator, we use 1 stack with like a minus and a +1 for the sign. For this one, we just use 1 stack with 2 passes. So what it means is, so it will have 1 stack with integer. Like I said, this is actually a bug. This is a solution I copied from the Leetcode discussion. So I have a link down below here. You can check out. They just use the integer, but it won't work for the long case. For the extreme case I posted, the integer dot maximal case, 0 minus integer dot maximal. So the sign, this is more like actually the previous sign instead of the current sign. As you can see, first it will assign to be plus. So that means basically this one carries a plus sign. So it basically checks the character and then keep doing the sum. And now this is the interesting part. If it is actually a sign, you will see, okay, what is the previous sign looks like. If it's a positive, just directly push number, or if it's negative, we just directly push the number. For negative ones, we times -1 and then push the number because for example, if this is the case, this is a previous sign. If you have a 2, you actually want to push -2, right? And then this is only the first iteration. So if you have either a multiply or division, so what it does is actually pop up the stack, do the calculation, and push the things back, right? And then this is basically, you can think about the first iteration is only solving the times and the divide case. And then we'll have a second iteration. This iteration is solving the plus and the minus case. And because you already have the sign, all you need is actually plus them together because negative number is already negative. So let's quickly run through one example. Let's say this is still the example. So what it has is, first of all, it will assign a sign to be actually a positive, right? And then you see first the number is 1, and then you calculate it here. the number is 1, and now this is nothing pushed to the stack yet. And then you see a sign, which is a negative sign, but that is your current sign, which is s.char at, right? And then what you check, just to be, this should be actually named as a previous sign. And then your previous sign, which is in this case is the sign, is actually plus. So what that means, you need to push the number. So you actually push a +1, like a +1. Let me just write it a 1, just don't confuse. You actually push a 1 into the stack. And now you reassign the sign to the current sign, which now the sign is actually a negative, if this is a sign. So right now it's actually a negative sign, okay? And now you continue this. So now you have a 2, okay? That is fine. And then you have another sign, which is a times sign. So what you need to do is, okay, but what is your previous sign? So when you are here, so that means basically you have a minus times number. So your current number is 2 right now. So basically you push 2 here. And now your current sign is actually times, right? So this is gone. And then you're doing this 3. So remember, what you want to do in this kind of situation is you actually want to calculate the times and division, and then in the first iteration, and then so that you keep the stack purely is plus and minus case. So once you read this 3, so you have the 3, and then because your current sign is actually a times, what you need to do is you pop it out and then pop times the current number. So you have the 3, you pop up -2, so this is actually -6, you push in -6. So that's the thing. And now you have to update your current sign is actually a division, right? And then you have number 2. So what you need to do is you actually do this. This equals to -3, so you push -3 in, so those 2 are out. And that pretty much concludes your first iteration because you already reached to the end. And then in your second iteration, all you need to do is sum all the numbers in this stack together, which equals to -2. So this is a relatively clean method just for this approach. However, using 2 stacks, one with operator, the other with operands, is more generic. So, but this one for this problem looks good. I would still prefer using the generic method. It's more like a template so that you can use this to solve any kind of expression problems or calculator problems. All right. Yeah, that's all. Thanks a lot for watching.